Here we go, day 4. How many rolls of paper can be accessed by a forklift? Forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. There are 13 rolls of paper that can be accessed by a forklift marked with an X. 8 adjacent, so in every direction. So the rolls of paper at signs are arranged in a large grid. The elves even have a helpful diagram. If there are fewer than 4 rolls of paper in the 8 adjacent, if there's less than. So for instance, this X is here because we have less than 4. We only have 2 technically, or 3, including that one before it. I remember doing some puzzles like this in the last couple of years, and it was a pain in the butt. And let's see, probably one of these. And I'm not going to go through and find it, but okay. So for every single line, we're going to go through, and then we need to go down and up. So let's start with up. It's going to be the up line is going to equal data index -1. And we're going to get an error here. No, why not? So we want to go up the last one. We want to go index. That should print everything. Subtract 1. Circles all the way back. That's crazy. Okay, if index is going to equal 0, we're going to continue for go up. We're going to pass elif index is greater than 0 and the length of data and the index is equal to the length of data plus 1. Excuse me, index like that. I'm going to print hit. Let's just make sure we get in there. Upline is not defined, sure. We should hit it once because that gets us at the very end and we skip this. Go down. Check current line. Okay. Else we are going to take the line from before. So, okay, this is where we get upline is going to equal the data minus index minus 1. Right here, we're going to have the down line is going to equal the data of index plus 1. And then what do we do with it? We want to basically have it say we want to check -1. So we want to take the, let's see. Up left is going to equal up line. Index minus 1. Up center is going to equal upline index, and up right is going to equal the upline index plus 1. You're going to have left here, it's going to equal line index minus 1, and right is going to equal line index plus 1. This is certainly going to bite me in the butt on part 2, how I'm setting this up. And then we are going to have down left, down line index plus 1. Down center is going to equal down line index, and down right is going to equal down line index plus what I want, negative, wait a second, down left something like that. And then once we have all of those, we're going to say equals an @ symbol. We basically want to know if it's true or not. Boop, 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 boop. And then we're going to say, after all this valid, it's going to equal this plus, let's see here, we want to sum them up, true or false. Let's do some comprehension here. We're going to say, because they're going to come out as bools, but we want to count the bools. Actually, I think this works because sum will sum truthy values. Will it? Let's try. Sum of true, false, true should be 2. And you got to program in the language that you're using, folks. Today's language of choice is Python. Yay, that actually will work out. So we're going to say this, 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 save, number valid, and then we will plus equals num valid is going to be at 0, and then here we will print num valid. We're missing an L. What's wrong with you? Ambiguous. I don't care. Okay, challenge. Whoop. UL, UC, UR equals false. Oops. And that still isn't right because yep, this might not be set potentially because we didn't do this. If the index is greater than and the index equals that, DL, DC, DR equals false, 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 else, I think is how we want that. And then, yeah, we need to ignore each of these individually. I don't know that this will work. Yeah. We could I don't love this, but we can try this. There's a simpler way, but under pressure, I can't often think of them. And then we'll basically rinse and repeat here. DR, try that again. R. Sure. And we'll try, this is terrible. I needed to have functionized this. That actually would have been a brilliant idea. I'll clean it up in the end. 57. Woof, that is so much higher. Okay, so let's think on what's happening here. Let's go through one line, get to the end, and then let's break out and print out number of valid and see. So we get 3 on the first line. If there are fewer than 4 rolls of paper in the 8 adjacent. Oh, right. So we just counted up the number of adjacent rolls. We need to see if it's 4 for a particular single. Oh, wow. See, I think what I actually want here, I'm only checking line by line too. I'm not checking character by character either. Woof. Okay, so for character in the line, we're going to go character index. Yep, so if the character index equals 0, nope, if the line index equals 0, we can't go up. Otherwise, we need to go up the line, up left. That tracks, that tracks, that tracks. Whoops, that needs to be index error. Here we need the character index. Oh gosh, what does that become? 546? I think that's 546 checks, basically. So now what we need to do is when we get to the end of a single character, we say is valid, and if the sum of those is less than or equal to 4, and then what we can do is how many rolls of paper can be accessed by a forklift. Then we say the total num valid plus equals 1. If we get 2 on the first line, which is now too low. We're very close, I feel. Okay, so if you can't go up, then there wasn't one there. Okay, so for this first position, up and left is false because it doesn't exist. Up, center, up, right is false. Okay, then the left of it is false because it doesn't exist. Right of it is true, is false. Oh, why? That one's true. No, it's false because there's not a thing. Oh, fewer than. So yeah, do I want to be flipping the script on these? If it does equal that, true, 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 false, 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 false. That still isn't. Wait, whoa, what did I do? Up left. Up center because it will exist. Oh, I see. Oh no, it's still false if it's out of. Yeah, okay. I also want to print the character. See, this goes from a dot to an immediate and symbol. There should be 2 dots. I'm confused. Okay. Here we go. So we're just starting with the top one. So top left is false, up is false, right is false, left of it is false, left of it is false. That's 4. The 5th one is right of it. Well, that's also false because it is a dot. And then bottom left is true because no, down left should be false because it's an index error. So then we must not have this correct. We want the, oh yeah. So we need down a line and then character index -1. Up a line, yep, okay. Up a line, up center is going to be the character index. This one, +1. Left and right stays. Down a line, character index, character index. This one is just the character index. And string index is out of range. Why? Oh, duh. Because we already go up the line. So we need to get rid of this one so it's not double, or I guess triple done. Then this one stays. Then this goes away. I just had him looking at the wrong index. So we've got false, 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 and then down left, this should still be false. Print down line, aka the next line, which is correct. Got the next line. Okay, if the character index is 0, then UL is going to equal false. Elif, the character index equals +1 equals the length of the line, then the right one is going to be false. Same here. If the character index, let's see. Yeah, if the character index equals 0, DL is going to be false. Character index +1 equals the length of line. Then DR is going to be false. Okay, fix that problem and clean up the code a little bit. So now we've got false, 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 because the left one doesn't exist here. True, because we get that, and true, which means that if we go back here, how is that not fewer than 4? We have fewer than 4 for this one. That literally doesn't make any sense. Oh, it wants to know which rolls of paper can be accessed. Oh, my lands. So we don't even need to be doing it on that one. Character. If the character equals a dot, we can break out of the character check and continue on. Sorry, we can continue on. We get 6, 1, 2, 3, 4, we've got 5. That should be in there, so we're actually close. This one is not valid because it's got 1, 2, 3, 4. Fewer than 4. So I actually think this will finally work. We need not less than, fewer. We get 5. Fantastic. If we remove this break, we get 11, which is close. It's not 13. Probably because this has the same problem as these ones. Yep, so if we just do this, else, and this, else, whoops, 13. $13,993. Ayo. Okay, once a roll of paper can be accessed by forklift, it can be removed. Once it's removed, the forklift might be able to access more rolls. Starting with the same example, here's one way you could remove as many rolls of paper as possible, using the @ symbols to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. I want, let's see. The string list character index is going to equal the X, and then I'm going to put that back in there like that. Out of range. Why? Again, at. Cool. Yep. So we get the string list. Then in the string list, we get the character index. String object does not support item assignment. It's not. It's a what? It's an element of a list. Oh, this one. Data. All right, we never recursed. But why do we get 27? We should still have. Oh. Wow. Copy equals data. Before we do anything to it, we need to do this to the copy, I think. No. Well, yeah, why does that count up higher than before? Should still be 13. Is it because we'll go back to 13? Okay. So that copy didn't actually work. Assigned but never used. Is that a thing? And then we can. Oh, okay, yeah, good. But now if we print copy after it's all done, we should have some X's in there. Fabulous. And then if we count up the number of X's, right? So then we because after you recurse, you can. Oh, we could leave the X's actually. No, we can't. We have to remove them because as we see here, we need to retain this X. Oh no, we don't. Calculate is what we're going with, and we're going to do data and copy and line index and line and character index and character. Methinks. And calculate data copy, line index, line, character index, character, I can spell. Oh, it doesn't know this is in a loop anymore. Are there any other breaks? Okay, let's go back a day and look how we recurse this. We had a break out here. We return the function itself again. Basically, by the end of this, if... Yeah, we do need to replace those x's. If the copy does not contain... If copy doesn't contain any more x's, we got to the end. We're going to count part 1, part 2. We're going to make it a dot instead, and we're going to say num removed plus equals 1. And we're actually going to put this here, num removed. The data, num valid, num removed. Valid, num removed. Okay. Maximum recursion hit. All right, so we're recursioning. And then we need to do this part. So if for line in copy, if there's an x, oh shoot, put the x in. If there's an x in line x found, it's going to be false. X found equals true. If x found, if x is not found, we can return what? Num valid, num removed. And then when we get to the end, true, for line in copy. Line dot replace x's with dots. Print copy. I don't know if that'll. List object has no attribute replace. Print line. Can you stringify? No. Yeah, join. So we could join the line like that. Okay. So we're going to join the line first and then replace. Then we get copy. Oh, we're really close. Okay, that for the first line is correct. Second line looks correct. So the first iteration is correct. By the time we get here, that's all right. We obviously have some x's. So let's try it again. Okay, we're not actually replacing them. I didn't think so, which is too bad. Meaning we need the copy line index to become that. Which did nothing. Well, because line index is long gone at this point. Okay, that might work. 43. I think that was the answer, 43. So now we just gotta hopefully run it with this. Oh, let's go. That's awesome. Way cool. Okay. Wow, wow, wow. Sorry, answer 1, empty, answer 2, get the answer. Part 2, we basically need to tell it to not recurse on part 1. If part equals 2, do all of this. Else return number valid, number removed. Part. Huzzah. Right, if I go back to sample, that should give us the, yep, okay. So this is what's happening. We have a set of we've got a set of rolls of paper with an @ symbol. And every time that we go through here, we want to check, hey, can the forklift get to it? But it can only get to it if it has fewer than 4 rolls adjacent to it. So that's any of the 8 squares. So if I took well, I can't, but this one right here, you got to go up and left, up and right, left, right, down and left, center, right. So it's quite taxing. And so what we need to do is basically that. We're going to go up a line by going up the index. If we're out of bounds, just make sure that everything is false. We go up the index and we check if it's out of bounds, it's false. If it's out of bounds, it's false, going left and right. Otherwise, we assign a truthy value to up left, up right, etc. We do the same thing for the current line, just going left and right. We go down, so we flip all those indexes. And then what we do is we add all of these together and we sum them and we say, hey, is that less than 4? If so, it's valid. And we mark that number, we increment that, and that's it. They wanted to know how many rolls were accessible by a forklift. On part 2, it wanted you to use probably some kind of recursion. There's probably other ways, but I decided to do recursion. So I kept all of this logic and added a tiny little piece that basically copied the original data and said, hey, every time you go through this, we're going to copy the list, mark off the rolls that we counted as valid with an X, reassign it back to the copy so that it updates, increment our number, and then if we were on part 2, we want to check if we still have any X's. If we do have any X's, we're going to continue on. If we do not have any X's, we got to the end. And as you can see here, as you continue to remove these rolls, aka the X's, you get down to a point where you can no longer remove any based on the rules we described. And so then we can join the line together, replace our X's with dots to know that we have finished that section. We call our function again so that it keeps going and going and going until we're done, and we are left with the answer, which in my case is 1393 and 8643. So hope you enjoyed, and I'll see you tomorrow.